Okay, so we are going to look at this next section here, simplify and factor expressions, and it all comes from the stuff that we were just doing on the other page. Those trig identities that we have to know to be able to simplify these. So a lot of times the easiest thing to do would be, or one of the easy things to do, would be to rewrite these. It says use a quotient identity to simplify and rewrite. So cosine, can't really do anything with that, right? It's cosine, we're going to leave it as it is. So I have cosine beta. Tan, though, I could rewrite tan as its quotient identity. That's these over here. And remember, tan is sine over cosine. So I have sine beta over cosine beta. Now these two things are multiplying, right? So if I put cosine beta over 1, the good thing about this is now the cosines are going to cross off, and we are left with sine beta. So we have simplified that. Usually when we simplify, we get it down to one operation, which is what we have there. Okay, so if we look at B, secant x, cotan x, sine x, what we really want to do, it says use quotient identity, which yes, but anything that's not written as sine or cosine, it would probably be helpful if we wrote them using sine or cosine. So secant x, we know secant is the same as 1 over cosine x. Cotan x, if you need to look back over here at that. So cotan x is cosine x, or cosine theta over sine theta, which we're using x's here, which is fine. I lost my screen. So we have cosine x over sine x. And then sine x, we don't have anything to change, so we're just going to leave it as sine x, and we can put that over 1. Yay, because look what all is happening. My cosines are going to cross off, and my sines are going to cross off, and we are left with O1. Okay, so sometimes on these, like on number 3, example 3 here, A and B, you might want to decompose these fractions, which means you don't want it to be, we can just kind of finagle these fractions. So cosecant theta, I just have there, right? It's cosecant theta. But I could rewrite sine on the bottom as 1 over sine theta. Now here we could probably just change this cosecant theta to 1 over sine theta times 1 over sine theta, which we know from the page before, when we multiply that, we have 1 over sine squared theta. And 1 over sine squared theta is the same as cosecant squared theta. Okay, so if we look at B, sine x minus cosecant x over cosecant x. So again, we would decompose these, which this one meant that we wrote it as a product, right? And it was just 1 over sine for instead of divided by sine. Now this one, because we have a difference in the numerator, both of these are getting divided by cosecant x, right? So I could write this as sine x over cosecant x minus, and then we have cosecant x over cosecant x. So we're always looking to simplify. We would notice here that these two are going to divide out, which they do, but this sine x had to get divided by cosecant x. So this one is very similar to this one now. I have sine x times 1 over cosecant x. And from the page before, we knew 1 over cosecant is the same as sine x, and we still have minus 1. And sine x times sine x, sine squared x, and minus 1. And that's as far as we can go with that.